So the major functions of the stomach: they receive the stored ingested food where it is mechanically broken down, and it's disrupted of the chemical bonds in the food by acid and enzymes. Remember that the pH, or the acidity in the stomach, is very low. It's around 2. We talk about acidity and alkalinity a bit later. And it produces what is called intrinsic factor, a glycoprotein used in the absorption of vitamin B12 in the small intestine. So here we have the diagram of the stomach. You're not expected to know all of the names of the stomach, except that we have the esophagus entering one end, we have the esophageal sphincter, we have various muscle layers of the stomach, and then we have the pyloric sphincter. The pyloric sphincter is where the end of the stomach joins onto the duodenum. So in the fundus of the stomach, the top part of the stomach, is where we get gastric glands, where they secrete hydrochloric acid, so the parietal cells and the chief cells. The parietal cells are involved in hydrochloric acid secretion, very important to keep the pH low in order to be able to break up the food. And the chief cells secrete pepsinogen. The pyloric glands, so we're down a bit further in the stomach, so they are scattered with through the stomach, and they are where we find the G cells and the D cells, and they have specific functions. So they secrete gastrin, and the D cells secrete a substance called somatostatin, a hormone that inhibits the release of gastrin. So we don't want gastrin still to be secreted if the stomach is empty of food. Otherwise, then the wall of the stomach is at risk of being digested through autodigestion. So the D cells can pick up when the stomach is empty of food and inhibit the release of gastrin. So here's a microscopic look of the stomach wall. You can see it's got all of those, the mucosal layer, and we have what are called gastric pits, and at the bottom of those pits is where we've got the cells. So this diagram is just showing you the mucosa, the submucosa, and the muscularis externa. And we've also got with you here, because now we are in the peritoneal cavity, the serosa, or the visceral peritoneum. Here's a close-up view now of one of those folds, and below the gastric pit we have the gastric glands, where we have the G cells and the chief cells, where they are secreting their the hormones and the digestive enzymes. The regulation of gastric activity is controlled by the central nervous system, and it's regulated by short reflexes. Regulation of hormones by the digestive tract, and gastric activity has 3 phases. So we've got the cephalic phase, the gastric phase, and the intestinal phase. So the cephalic phase, which is to do with the brain, is when we have the sight, the smell, and the taste, or the thought of food. You know, if you think about your favorite food, you can get your mouth watering, which means that the salivary glands start secreting saliva in readiness for that food to enter the mouth. In the stomach, the cephalic phase is also involved in the secretion of enzymes from the mucosal cells, the chief cells, and the parietal cells. And also we've got the G cells. So parietal cells secrete hydrochloric acid, the chief cells secrete pepsinogen, and the mucous cells have to keep secreting mucus to keep coating the mucosa and protecting it from the hydrochloric acid. The neural phase, when we're looking still at the gastric phase, it's involved in the elevation of the pH, and it will cause more parietal cells to secrete more acid. So it's important that it's a complex process, so that the food is broken down so it can be exiting the stomach in a form that the duodenum can accept it in order for absorption to occur. So here we've got, in the presence of the duodenum, we've got other enzymes that we're going to talk about in a moment, where we get, so now we've got the food where it's now, it's called chyme, and it's ready to move on to the second phase of digestion in the small intestine. So the stomach contents become more fluid, the pH approaches 2, so it's becoming more acidic, pepsin activity is increased, and protein disassembly begins. Although a digestion occurs in the stomach, there is no absorption of nutrients that occur there. That all happens in the small intestine and the large intestine.